Hello children, welcome to our class. Now the continuation of physical world. See, in that we are going to learn the fundamental forces in nature. See, in that previous classes, in lower classes, we have observed several kinds of forces like muscular force, contact force and friction, forces exerted by springs, strings and viscous force, right? Electric forces, magnetic forces, like we have studied about these forces, and atomic and nuclear process of forces also we have studied. See, these kinds of forces come under the macroscopic force and microscopic force, we can say. See, these are the fundamental forces which are segregated into that four, that is nothing but gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. So we can see elaborately one by one. What is gravitational force? See, it is the force of mutual attraction between two bodies by virtue of their masses. See, it is a universal force. Every body attracts each other, right, of the universe with this force. See, according to Newton's law of gravitation, the gravitational attraction between two bodies of masses m1 and m2 are separated by distance r. Okay, that m1 m2, the masses, is directly proportional to the force, and the force which is inversely proportional to the square of the distance between them. So that F which is equal to G m1 m2 by r square. See, this G which is nothing but the universal gravitational constant. Okay, what are the important properties? Some important properties which is there on the screen. It is a universal attractive force. The gravitational force is the universal attractive force. It is directly proportional to the product of the masses of two bodies, we said. It obeys inverse square law, right? And also the gravitational force between two bodies does not depend upon the presence of other bodies, right? And it is a conservative force too. That means the work done in moving a body against the gravitational forces, the path is independent. Okay. Now, next one is example we can see. All bodies fall because of the gravitational force of attraction exerted on them by the earth. See, what is gravitation? See, the gravitational force between two bodies is thought to be caused by an exchange of the particles, right? That is called the gravitation. So, gravitational force which governs the motion of the moon and the artificial satellites around the sun, around the earth, and the motion of the planets around the sun, right? And also this gravitation plays the key role in the information and the evaluation of stars, galaxies and galactic clusters, right? What is electromagnetic force? See, this is the force attraction between the electric charges at rest, right, which is called electrostatic force, which we know, both together, which is nothing but the electromagnetic force. That what is that? According to Coulomb's law, the magnitude of the electrostatic force F between 2 point charges, which is there in the first diagram, right? Q1 and Q2 separated at a distance r. Okay, so F which is equal to K Q1 Q2 by r square. Here the K which is nothing but the value 1 by 4 pi epsilon naught. The epsilon naught which is nothing but permittivity of vacuum. See, the force attracting or the force is acting between two magnetic poles, which is called what? Magnetic force. See, in fact, electrostatic and magnetic forces are closely interrelated. For example, a moving charge produces a magnetic field. We know that. Also, a magnetic field exerts a force on a moving charge. So, this force depends both on the magnitude and the direction of the velocity of electric charge. So that the electrostatic and the magnetic forces are inseparable and are considered two facts which are together. So that this general force, which is known as electromagnetic force. So it has some important properties like the same like gravitational force. It is a universal force of attraction and repulsion between them, and it also obeys the inverse square law. It is a conservative force, right? So some of the examples in this: when a spring is compressed or elongated, it exerts a force of elasticity due to the net repulsion or attraction between its neighboring atom. See, this net repulsion or attraction is the sum of electrostatic force between the electrons and nuclei of the atom. Right. So the next one is the strong nuclear force. What is strong nuclear force? The strong attractive force which binds together to the proton and the neutrons in a nucleus, which is called strong nuclear force. See, actually this force cannot be electrostatic force because positively charged protons strongly repel each other at such small separations of, for example, it is approximately in order to 10 power minus 15 meter, right? And also the gravitational attraction between two protons being much weaker cannot overcome the electrostatic repulsion. See, so a new attractive force must be acting between the nucleons, right? That means proton and the neutron. So this strong nuclear force is the strongest of all fundamental force, about 100 times stronger than the electromagnetic force, we can say, for example. So what are the important properties of this? See, what we said, this is the strongest force, so that it has strongest interaction between them. That means it's about 10 power 38 times stronger than the gravitational force. It is a short range force that operates only over the size of the nucleus, right? It is a non-central, a non-conservative force. That is also important. Non-conservative force. Some of the example in that, see, the radioactivity occurs in heavier nuclei because of insufficient nuclear force between their protons and neutrons, right? See, the concept of nuclear force is useful in obtaining nuclear energy via the process of nuclear fission and the fusion, right? Next one is weak nuclear force. Weak nuclear force, which is nothing but it is a force that appears only between elementary particles which are involved in the nuclear process, such as the beta decay of a nucleus. So for example, in a beta decay, the nucleus emits an electron and an uncharged particle called neutrino. See, the electron and the neutrino interact with each other through the weak nuclear force only. See, the weak nuclear force is much stronger than the gravitational force, but much weaker than the strong nuclear force. That's why we call it as a weak nuclear force. And also it is weaker than the electromagnetic force too. So, okay. This is obviously, we can say that from the fact that decay of an elementary particle caused by the weak nuclear force. Right. Some of the important properties we can say that, see, the weak nuclear force is 10 power 25 times stronger than the gravitational force. Right. Thank you, students.